Welcome to the 9th episode of the Python tutorial series. Our topic for today is while loops. These are a more advanced form of iteration than for loops and can sometimes be a bit tricky to work with. So let's see how they work. First, let's look at the difference between for and while loops. For those of you who watched my tutorial, I'm sure you remember that for loops work with an iterable, so they iterate through a list, a tuple, a range, a series, or pretty much anything that can be iterated through. While loops, on the other hand, rely on a condition. What does that mean, you may ask? Well, let's see an example to make it clear. In a typical while loop, we have an initial state, the while command, accompanied by a condition, and then we have an action. In this case, the initial state is the variable a being equal to 1, and its condition for the while loop to continue iterating is that a is smaller than 4. The action constitutes incrementing the variable a by 1 each iteration. So, the resulting actions that are performed by this loop will be, for the first iteration, a will be plus equals 1, so a will go from 1 to being the variable 2. Similarly, in the second iteration, a will again be incremented by 1, and a will become 3, etc., etc. In this case, a, once it reaches the value of 4, it will no longer satisfy the condition a smaller than 4, meaning that the while loop will stop. Now let's see a slightly different while loop. If our initial state is for two variables a and b to both be equal to 1, our while loop could again be a while a smaller than 4, so the condition is that a has to be smaller than 4, and the action being performed is that b will be incremented by 1. Can you spot what's wrong with this while loop? If you can, pause the video and comment below to see if you're right. For those of you who haven't spotted it, just think about what's actually happening here. At each iteration, the variable b will become greater by 1. But the variable a will always be equal to 1. In other words, the condition will always be met, and therefore this while loop will iterate forever. If this happens, make sure to stop your code using one simple command, Ctrl+C. This is the most useful command you will encounter in coding to prevent accidents such as this. But now that we've seen what can happen with an improperly constructed while loop, let's look at some examples of how to use a while loop in a piece of code. For our first task, let's use the same example we used in the previous tutorial and substitute the values in a list with their squares. The first thing to do is write the list to be converted. So we will call it our list, and it will be comprised of the values 1, 2, 3, 4, 5, and 6. Our second step will be to calculate the length of this list. Now, as in the previous tutorial, we will call the variable length of list, and this will be equal to len of our list. Our next step is to set up a counter. What this does is keep track of our index, and that way we can make sure that it does not go beyond the length of our list. We will call this counter I and set it to 0, which, as we know, is the index of the first element in our list. Now let's formulate the while loop and say while I, and now we have to put the condition and the condition will be for I to be smaller than the length of our list. So we'll write while I smaller than length of list. Now for each index we will extract the corresponding element from our list. We will do this by calling the variable element and making that equal to our list I. Now let's square the element we have just isolated and call this variable element squared. And this will be equal to element double asterisk squared. Make sure to use the double asterisk, otherwise you'll be timesing it by 2 instead. Now let's reassign this newly calculated element to our original list by calling the name of our list, followed by the index I to indicate that we are inserting this element in the ith position, and making that equal to element squared. Last but not least, we have to remember to update the counter. So I plus equals 1. Now, as you can see, this is a shorthand operation. If you can't remember how to use this notation and want to revise the topic, make sure to check my tutorial by clicking on the banner in the top right-hand corner of your screen. Returning to our code, the last thing we have to do is print the list so that we can check it has produced the correct results. We can do this by calling the print command and say print our list. If you can't remember how to use the print command, make sure to check my tutorial on the print and range function by clicking again in the top right hand corner of your screen. So now let's revise our code. First, we wrote the list to be converted, and then we calculated its length. Then we set up a counter to keep track of our current index, and then ran the while loop for all the indices between 0 and the length of our list. For each index, we extracted the corresponding element, squared it, and then reassigned it to our list. Then we updated the counter to make sure that our while loop does not continue forever. And last but not least, we printed our result. As usual, if we press the F5 key on our keyboard, we will run the code and we will see in the right hand side of the screen that the result is now 1, 4, 9, 16, 25 and 36, which is, as expected, the square of all the numbers in our list. Now that we have completed the first piece of code, let's look at a second, slightly more complicated example. For our second example, let's use the same case we used in our previous tutorial. We now have to calculate the cumulative sum for each element in a list. So first, as usual, let's write the list to be converted. We will call it our list and set that to be equal to 1, 2, 3, 4, 5. Then we will create an empty target list that we will use to record our results. As usual now, let's record the length of our list and say that that is equal to len of our list. And as before, we need to set up a counter to keep track of the indices of our elements. So we will write I equals 0. Now we will start our while loop. So we will write while I is smaller than length of list. Then for each index, we will extract its relative subset of elements by writing subset equals our list of 0 to I plus 1. If you want to review this type of indexing technique, make sure to watch my associated tutorial by clicking on the banner in the top right hand corner of your screen. Now that we have created our subset, let's calculate its sum by writing result equals sum of subset. Then we will append this result to our target list as we did in our previous tutorial. So let's write target list dot append result. Finally, as in our previous example, we have to update the counter. Otherwise, as I'm sure you remember, the while loop will not terminate and will carry on forever. So let's make sure to write I plus equals 1. Finally, we will print our target list in order to make sure that our results are correct. So we will write print target list. Now, as usual, make sure to review your code to make sure you haven't made any mistakes. So, the first thing we did was write out our list to be converted. Second is we wrote an empty target list to record the results of our operations. Then we calculated, as usual, the length of our list, and we set the initial counter to be 0. Then we started our while loop, and for each index we calculated its subset, as well as the sum of the subset, and then we appended this result to our target list. And then for each iteration, we have to remember to update the counter. Finally, we print our target list to make sure the results are correct. Now that you have reviewed your code and made sure that it is all correct, press the F5 key to run it in your terminal. There we have it. As you can see on the right-hand side of your screen, we now have the result 1, 3, 6, 10, and 15, which is exactly the cumulative sum of each of the elements in that list. So, we are happy to say that our code works. Now, let's recap the main concepts we learned today. While for loops use an iterable to define the number of loops, while loops use a condition. So make sure that you update your counter such that that condition is satisfied at some point in time. Otherwise, the while loop will carry on forever. If you want more information on for loops, make sure to click on the banner above to access that tutorial. If you've missed any of the previous tutorials, make sure to check them out as soon as possible by clicking in the links in the video description. This brings us to the end of this episode. If you have any questions at all, leave a comment below. Also, make sure to like and share this video, subscribe to the channel, and turn on notifications so you don't miss any upcoming videos. I look forward to seeing you next week in the new episode of the Python tutorial series.